All right, example number 3, writing and solving an equation. And something tells me it's going to have something to do with variables on both sides. Let's find out. So it says the circles are identical. What is the area of each circle? And then it gives us choices A, B, C, and D. So I see the two circles. I've got the top one, the green one, that has a radius of x plus 2. And then I've also got the bottom circle, which is purple, and it's got a diameter of 4x. But I do know from experience that a diameter is equal to 2 of the radiuses. So if I wanted to compare those radiuses, um, and it says they're identical, so they're going to be the same. I know that 4x for the whole diameter, so I could take half of that, which would be 2x. So technically, this purple circle has a radius of 2x since it has a diameter of 4x. So that one's radius is 2x, and the green one's is radius is x plus 2. So because these circles are identical, I can actually set these two equal to each other in order to work towards finding the answer of what their area is. But in order to do that, I would need to know the value of the x. But I can actually solve that by setting them equal to each other since they're identical. And now I can solve for x because I've got an equation. So I will draw in my wall first, and I'm going to circle my variable terms. And just to make note, I'm just going to draw an underline underneath this too, because that's just a constant term. So it looks because I have my constant here on the left, I actually probably want to move my single x across the equal sign to the other side just to save steps. So in order to get rid of a positive x, if you want to move it to the other side, you would have to do the inverse operation, which is to subtract an x. So that would cancel out. And now I have to simplify the 2x minus x. So that's like 2 minus 1, so it just leaves me with positive x, which is pretty convenient because on the other side, all I have left is positive 2. So we find that we get an x value of 2, which changes everything because now we can actually use our area formula to figure out what the area of both circles are. Since I know that x equals 2, I'm actually going to erase all of this so I can make some room. Hopefully you have some more room on your paper. So now I'm aware that x is equal to 2. So when I take a look at this green circle, I could substitute this value of 2 wherever I see the x. So if I were to substitute that 2 in for the green circle, I see that the radius is equal to 2 plus 2, which is equal to 4. And then hopefully, since the other circle is supposedly identical, hopefully it's equal to 4 also. But I'm going to do that by substituting the 2 in where I see the x. So if I do 2 times 2, I actually end up getting 4. So they're both equal to 4, so far so good. However, 4 is the distance of the radius, so just that small little distance from the center of the circle to the edge. But they're asking us to find the area of the circle. And in order to solve that, I need to remember that the formula for finding the area of a circle is area is equal to pi r squared. So remember I said that r is equal to 4. Our radius was 4. So where I see my r in this equation, I'm going to actually substitute the value 4. And then I'm going to simplify and multiply everything out. So I'm going to bring down my pi and I'm going to bring down my squared. And I have to simplify this, so I can't really do anything with the pi yet. I would want to simplify that 4 squared, though, and I know that 4 squared means 4 times 4, so that is 16 times pi. And it looks like our answers up at the top are actually written, well, actually 2 and 4 are not, but 16 and 64 are written in terms of pi. So we have this answer of 16 pi right here where we see the letter C. So the answer is C, 16 pi.